In this video here, we're going to talk about some different biases that can affect your model training when you're using computer vision, but could be anywhere when you're dealing with AI, machine learning, and so on, where we have a data set a model is learning patterns from. In this video, we're going to cover AI biases, different types, how we can prevent them, how we can get around them as well, and basically just understand what is AI bias and also dataset bias when we're talking about computer vision systems. So let's just jump straight into it. We have this blog post here on the Ultralytics website, tons of other blog posts, videos on the YouTube channel and so on. Definitely check out those if you want to get into more details, dive deeper and so on. So we're going to cover this here. I'm going to talk about it, but mainly we're going to explain the different graphs and the figures that we have in here, basically just to understand it. So when we're talking about what AI bias is and also why it matters, it's basically just that it affects the training. If we don't have representative enough data, if we don't have good enough data to feed into our model to train, because at the end of the day, the model doesn't know anything about the world. It doesn't have any reasoning. It only sees the data that you feed into it. So if there are some cases that you're not giving it examples of, if you're not giving it enough examples, it will not be able to learn from that. So it's basically not learning the whole world, it's just learning patterns in your data. So that's why it's so important to focus on the data set. Trash in is also trash out when we're talking about computer vision models, but any machine learning and AI model in general. So here, for example, imagine a model trained mostly on traffic images from big cities. If deployed in a rural area, it might misclassify unusual road layouts or like fail to detect different types of vehicles. So if you train it on a specific dog type, it's not going to be able to detect all different dog types out there in the whole world. So this is where AI bias comes in. Dataset is pretty much the most important. Like the model doesn't really matter too much if you're using YOLO v8, YOLO 11 and so on. The most important thing when you fine tune the model is have good quality data. So let's cover the main three biases that we have in AI and computer vision. The first one here is selection bias, then we also have label bias and representation bias. The first one here is basically just selection of the data that we're using. It's a really good example with if you only choose one specific dog to train our model on, it's not going to be able to generalize. So when we're talking about bias, optimizing our data set and so on, it is most often trying to reduce false predictions, but also just make our models even more general. Most people or a lot of people, they run into problems where the model, it doesn't work on when you actually put them out there in the real world into production. It only works in your training environment because the selection of your data, you have a population here, this is all the data available out there, then you only have a very specific selection. So that's like a subset of the whole world pretty much. And if you only train on that, you can't expect the model to learn the whole world or at least the whole population for your data set. So if you want to train on cars, dogs, whatever, make sure that you have good representations, be able to generalize, could even be lighting conditions as well. So population could be, here we have images at night, here we have at day. If you only choose images at night, it's not going to be able to do detections at day because remember, the models, they just learn patterns from the data that you feed into it. Then we also have label bias. So label bias is pretty much just incorrect annotation, inconsistent labels. Could be that you have some occlusions, people walking behind cars and so on. How do you label those? Do you label the full body? Do you label the occluded part as well? It could also be that how are you fitting the bounding box around the objects? Are you closely fitting it around? Could be people holding things and so on. Do you annotate both the hand and what they're holding or only the piece that they're holding? This is where label bias comes into account, and if you're not consistent in your labels, the models is not going to learn that. What you want to have in the output is basically what you need to have in the input as well, and then you just need to have enough. You need to cover edge cases and have a lot of variation and edge cases in your data set. Then the model output will also represent more what you act like wanted to. So biased world, data generation, learning, evaluation. So this is bias in data pipelines originated from real world imbalances. So we have observations, we have data, and then we have our model. So this is very important to focus on data, which also leads to the last bias here. So that is representation bias. Could be inequalities of our data, could be some data is more represented than other. Could also be that we just have more instances or cover more edge cases, have more variation for some of the classes. If you, for example, have 10 classes in your data set, and 9 classes, you have hundreds of examples, and then for a single class, you only have 5-10 examples. That's also going to affect the model. So that's also the representation bias that we're talking about. It's going to affect the model. It will most likely not be able to accurately predict the last class where we only had a few examples. And if we are able to, it's not going to be consistent. It's not going to be able to generalize to new use cases. It's pretty much the same as a dog example. The best one out there, best analogy to basically just think about. If we want to detect dogs, we just need to detect and label and have in our data set every single possible image of a dog, different types of dogs, different lighting conditions, and it couldn't just be a dog, it can be pills in a production line, manufacturing, any field. We need to represent all our data. So how to detect and mitigate data set bias? First of all, we need to identify potential biases. You need to look at your data set, the project, and the application that you're trying to solve. Then we need to define a fairness criteria. Pretty much just come up with your requirements and the criteria that is defined. Okay, this class here might not be so important, or it's maybe hard to generate so much data for that. So we have this specific criteria. Then we can audit our training data, basically just make our training data as good as possible, try to make modifications. There's a few tips and tricks, like for example, data augmentation. You can have more data diversity by using data augmentation. You rotate the images, change some lighting conditions and so on. Could also be use synthetic data set or synthetic data, mitigate the bias in the data. So we try to basically just remove it so we can have an evaluation, algorithmic fairness at the end here. So this is more like a pipeline. We need to go back and forth. You can't just take a data set, train a model, and you'll have the best model out there. We need to keep having like this active learning loop or data flywheel where we always like feed new data into the model, cover more edge cases, more conditions, more variations in our environments. So here we can see that we can use data augmentation. So we can flip the image, we can rotate it, we can adjust the lighting, we can scale objects up and down. So basically just simulate different real world conditions, changing environments. We have a lot of data drift when you take your models from your training environment into production environment, and a lot can go on. A lot of environments can change and so on over time. We don't want to retrain our models all the time. Maybe it's hard task, like most computer vision systems out there. The most hardest thing is actually coming up with a data set. Once we have our data set and a good data set, it's just a few lines with Ultralytics and you have trained a detection model of any kind. Synthetic data can also be used to fill out some gaps and so on, but try to use as much real data as possible. But synthetic data is really good to cover edge cases, which is hard to generate data of, or if you have class imbalances as well, it can also be used to be able to make your model learn that class as well, where you only have a few examples in your data set. So you can pretty much just take this, make the best possible data set, and then train it with Ultralytics. You can train a YOLO 11 model in just a few lines of code, and then you have your model. Then it's way more about focusing on getting the best data set as possible, representing the task that you want to solve. Hope you learned a ton this video here. This is very important if you're working with data science, computer vision, anything in AI and machine learning. This matters a lot because what goes into the model is also what we're going to get out of the model. Hope you learned a ton. Hope to see you guys in one of the upcoming videos. Until then, happy learning.